Well, hello once again, advanced algebra students. We're ready to go here and continue on with section 3.3. This should be our last day in 3.3, as we're going to look at trig ratios in the plane, specifically when we are looking at radians. So let's take a look at how this is going to be. What happens when your angle is in radians? Well, really, the first thing that happens is we have to locate where they are and then calculate the trig ratios. So locating the angle when they're measured in radians, there's really two options, and you can do whatever is easiest for you. You have a choice here. So the first option is convert radians to degrees. So if you're someone that really has trouble working with radians, just go ahead, convert it to degrees. So take your something that's in radian measure and multiply it by your conversion factor, that 180 over pi, change it to degrees, and work it in degrees like we have been doing. Your second option is quicker, but does require a little more ability to see what's going on. And that's consider as fractions of 180, or 180 degrees is equivalent to pi. So you can think of them as fractions of 180 degrees or pi. And I'll show you how you can do either one. And you'll see that number one probably is a little bit easier, but it takes longer. All right, so let's go ahead, let's take a look. So let's start off, let's find the trig ratios, so that's sine, cosine, and tangent, for negative 4 pi over 3 radians. So we have this in radians here, and even if they didn't tell us it was in radians, we would know it's in radians by this pi here. That's our big indication. And so before we can find the trig ratios, we have to locate this in the coordinate plane. So to locate it, option number one says convert it to degrees. So we multiply by 180 over pi. Now the quickest way to do this here is, notice the pi's cancel. 3 divides into 180 evenly for 60. So I get 4 times 60, which is 240. So I just have negative 240 degrees. That's one way to get it. The other way to get it is think of that negative 4/3 as being fractions of pi. So if I change that to a mixed number, that would be like negative 1 1/3 pi. So when I go to put this in place, I can go to my coordinate plane, and if I'm working in degrees, I can start here and go in the negative direction. So I start going down when I'm going in the negative direction as opposed to going up when I'm going in the positive direction. So I come down here around 90, 180, and then I need 60 more degrees right here to get to this location. Or if I think of it as 1 1/3 pi, 1 pi is 1 full turn, and 1/3 is another third of this pi here, another 60 degrees. So we can think of it that way. Anyway, knowing this is 60 degrees, I can now fill in my reference triangle. That makes this a 30, 60, 90. So I know that if this is 60, this is the long leg, radical 3. This is the short leg, it's 1, but it's negative 1 because it's going left. And then the hypotenuse is 2. Now I can answer my ratios. So my first ratio, I want the sine of negative 4 pi over 3. So this is just a review of what we did before. For sine, we look at the opposite side, which is this radical 3, over the hypotenuse, which is 2, so I get radical 3 over 2. Then I want the cosine of negative 4 pi over 3. So for cosine, I look at the adjacent side, which is always the side on the x-axis, which is negative 1 over the hypotenuse 2, so I have negative 1/2. And finally, for the tangent of negative 4 pi over 3, I look at the opposite radical 3 over the adjacent negative 1. So radical 3 over negative 1 is just negative radical 3. All right, with that, let's look at the trig ratios. Another situation that comes up that we have not looked at yet is what comes up when we have trig ratios of the multiples of 90 degrees, or we can think of them as the multiples of pi over 2. In other words, when we look at the angle, we are on one of the axes, either the x-axis or the y-axis. So let's look at what happens there. So let's consider first 0 degrees or 0 radians. It's the same thing. So if I'm at 0 degrees, I'm right there. I'm on the positive x-axis. Well, I don't really have a triangle. But if you want to think about it, what we would think about is when I'm here, I've got no opposite side. And notice it's like my adjacent side and my hypotenuse are the same. So thinking of it that way, I can calculate these. So when I go for the sine of 0 degrees, I know I have the opposite side, which doesn't exist, which is 0, over my hypotenuse. So 0 over anything gets me 0. So that's my sine of 0 degrees. My cosine, on the other hand, of 0 degrees, my cosine, the adjacent side, is the same length as the hypotenuse. So when I divide something by itself, I get 1. So my cosine of 0 is 1. Notice my tangent ratio, my opposite side is non-existent, it's 0. And my adjacent side we'll just consider as 1, but it doesn't matter. The opposite side is 0, so that means that it's 0 divided by something, so that is 0. All right, those are the three ratios for 0 degrees, or 0 radians. Now let's look at 90 degrees, or pi over 2 radians. So that's going to be going straight up. Okay, that's starting here and going to right there. So we're going straight up like that. So first let's consider the sine of 90 degrees. So notice here, now what's happening, if I think of my triangle, I don't have any adjacent side. The adjacent side is always the side here on the x-axis. There's no adjacent side. But my opposite side is the vertical side. It's the same as the hypotenuse. So this is 1. Opposite is the same as the hypotenuse. It's equal to 1. So when I look at the cosine, and I said pi over 2, it's the same angle. Pi over 2 is the same as 90. Notice my adjacent side is non-existent. It's 0 over my hypotenuse, which is 0. Now a very funny thing happens here with the tangent of pi over 2. The tangent is my opposite side, which I said is this value here, but I have no adjacent side. It's 0. So I have something over 0 that's undefined. So my tangent at pi over 2, or 90 degrees, is undefined. Right, let's look at 180 degrees. So at 180 degrees, we're right here. We're going out on the negative x-axis. So when I consider the sine, my opposite, there is no opposite, is 0 over the hypotenuse. So the sine of pi is just 0. The cosine, notice now the cosine, it's the same distance, but the hypotenuse is positive. The x-coordinate here is negative. So I've got two values that are the same, except that one's positive and one's negative. So when I take two things, like for instance, negative 2 over 2, or negative 1 over 1, or negative 3 over 3, I get negative 1. So that's my cosine of pi. And then my tangent, my opposite is 0. My adjacent is some constant, so 0 over something is 0. Finally, let's look at 270. 270, which is the same thing as 3 pi over 2, or 1½ pi. If you want to think of it that way, it's 1 pi for 180, and then another half pi. So that's 1½ pi. So notice my opposite side, that's this side here, it's down. It's the same length as the hypotenuse. So it's going to be negative, and it's going to be negative over, we're going to have the same values, so it's going to be negative 1, just like this one was negative 1 for the cosine. And then when I look at the cosine, the adjacent is 0. There's no adjacent side there, so it's going to be 0 over whatever that hypotenuse is, so it's 0. In tangent, we get the same thing that happened before at pi over 2. We have the adjacent being 0, the opposite having a value here that's negative, but something negative over 0 is still undefined. So those are our corresponding trig ratios there in the coordinate plane. Now, for your homework, here's our assignment. It's 18 through 25. and 37 through 44. One thing that is different though, on these, don't worry about what the book instructs you to do. Simply find all three trig ratios for the given angle that's there. So it doesn't say to find tangent, but you need to find tangent as well. So find the sine, cosine, and tangent, all three of them for each of the angles given there on those problems. Okay, hope that goes well, and hope you guys are doing well. We'll see you next day.